Alright, welcome to the probably going to be most painful problem of the review. This is asking us to find a whole bunch of derivatives by the definition. So we get to do a whole bunch of fun algebra here. Really test out those skills, make sure they're nice and sharp. And make sure we know the definition of derivative. And if it says calculate using the definition, if you use some other trick like power rule or just knowing it or any way you might do it, just keep in mind you're going to get very little credit for that because of the specific directions. It's definitely good to use those tools to check to make sure you got the right answer. I would absolutely support you in doing that. But if you just use that, if you use power rule and then say you did it, you're going to get the majority of the points off. So just to warn you. So A, we have limit as not x goes to 0, as h goes to 0 of x plus h squared plus 3x plus h minus 4 minus x squared plus 3x minus 4 over h. So polynomials are the most reasonable. As long as you FOIL correctly, you're going to be in good shape. So let's go ahead and do that. We have limit as h goes to 0 of, if you FOIL this thing, you get x squared plus 2xh plus h squared. We distribute this 3 plus 3x plus 3h minus 4 minus x squared minus 3x plus 4. And one really satisfying thing about these problems is that you get to cancel out a whole bunch of stuff. There's a minus x squared over there. There's a plus x squared. And if you did it right, you're only going to have stuff that has h on it. So you have limit as h goes to 0 of 2xh plus h squared plus 3h over h. Now we just factor out an h. 2x plus h plus 3 over h with a limit. The h's cancel. I'm left with limit of 2x plus h plus 3 equals 2x plus 3. And we could check this by the power rule and see that that is in fact the derivative. But if it says use the definition, you have to go through this process. Okay. So part B is square root of 2x. Again, you could use power rule to do this if you separated the square roots. Or you could use chain rule. But since we have to do it by the definition, we have to do it the not so fun way. So we have limit as h goes to 0 of f of x plus h minus f of x over h. That's the definition. Equals limit h goes to 0 of square root 2 x plus h minus root 2x over h. That's what happens when I plug in x plus h into this. So what do we do from here? We multiply by the conjugate. Sorry for the long pause there. I was copying down. So we get 2x plus h plus root 2x. Divide by the same thing down bottom. And when I do this, I'm going to get limit as h goes to 0. Let me put this in a new color. Conjugate. Okay. So remember when I multiply by the conjugate, on the top I'm going to get the square root of the left thing, or the square of the left thing, times the square of the right thing. So I have 2x plus 2h, distributing the 2, minus 2x over h times all this root stuff. And now this 2x cancels with the other 2x, just as the prophecy foretold. So we have limit h goes to 0, 2h over h, root 2x plus 2h plus 2x. The h's cancel. Again, let me do a different color. So I have limit as h goes to 0 of 2 over some other stuff. So now this is, if I plug in, I get 2 over root 2x plus 2x, root. I did 2 steps kind of at once there. I rewrote it without the h's anymore, and then I plugged in h equals 0. So I get 2 over root 2x equals 1 over root 2x. And that's our final answer. And again, if we tried either the chain rule or taking the root 2 in front of the x as a constant, we could get this answer. And works out. So that's 2 ways to check. But remember, see square roots, you should be thinking you need a conjugate. Next one, 1 over 2x plus 3. Limit h goes to 0, 1 over 2x minus 3. And that's what we're trying to find our new derivative of. This isn't right. I don't know why I wrote this. So 1 over 2x plus h minus 3 minus 1 over 2x minus 3 over h. So what do? I find a common denominator. So let me actually move all this stuff so I have enough room to write everything. What I wrote was correct, but I'm going to make sure I have enough room for everything here. So I get 2x minus 3 over 2x minus 3 times 2x plus h minus 3 over 2x plus h minus 3. And this will guarantee that I get a common denominator for these two things, which is my entire goal. So this is limit h goes to 0. I'm going to have 2x minus 3 minus, and then in parentheses, 2x distributing the 2 plus 2h minus 3 over, and then I don't try to simplify this denominator at all. I see some students try to do that and it doesn't work out particularly well for them. But I am going to distribute that too, because it'll make plugging h in a little bit easier for me. And then you get over h. So what's going to cancel? I have a 2x here, a 2x there, and I'm subtracting. A minus 3 here, a minus 3 there. And I'm not going to forget this minus sign like I always do. Limit as h goes to 0 of minus 2h over all this good stuff. 2x plus 2h minus 3 over h. And now I can kind of bring the denominator down. I'm dividing this whole fraction by h. So that's the same thing as multiplying it by 1 over h, which means I can now combine the denominators. And I forgot to write limit, so I need to go do that. Equals limit as h goes to 0 of this. So these h's cancel. And now I'm ready to plug in. So I get, preferably in a normal color, minus 2 over 2x minus 3, 2x minus 3, 2x minus 3 squared. And that is our final derivative. And we could check that relatively quickly by using the chain rule and the product rule. No, just the chain rule. You would write it as 2x plus minus 3 to the minus 1. Put the power down, that gives you minus 1 over 2x minus 3 times the derivative of 2x minus 3 is minus 2 over 2x minus 3. So that would be a way to check that your answer is right. And then, oh boy, do I have enough room for part D? I'm going to go ahead and assume not. If I can fit it all on one page, I would prefer to do that. So part D, essentially we do put what we did in B and C together. So I have, by the definition, this is going to be limit as h goes to 0 of 1 over root x plus h plus 1 minus 1 over root x plus 1, yes, over h. Now I do that same thing I did last time. So again, what I wrote was right, but I need to have some room. It's plus 1. So multiply by the denominators to get a common one. Let's move this over here. Over root x plus h plus 1. And then this whole numerator is bracketed off. Sorry for doing that. And now what do I get? Equals lim, h goes to 0. Whole bunch of stuff over h. And what exactly do we have? We're going to have root x plus 1 minus root x plus h plus 1 over, and then the two smashed together. H plus 1 times root x plus 1. Okay, a little tedious, but not bad. This is supposed to be an h. So this is limit as h goes to 0. And now I can put this h in the denominator, or put these denominators together. Again, if you're not sure why you can do that, it would be good to go back and look at that algebra again. A good reminder. It's good skills to be able to deal with fractions. But now this is the new limit we're trying to solve. And how do we fix this limit? Now we multiply by the conjugate. So root x plus 1 plus root x plus h plus 1 over root x plus 1 plus root x plus h plus 1. And finally, I get x plus 1, limit h goes to 0, x plus 1 minus x plus h plus 1, because the thing on the left gets squared minus the thing on the right squared. Square of a square root is just the thing inside. H root x plus h plus 1 root x plus 1 times root x plus 1 plus root x plus h plus 1. Having fun yet? The x's cancel, the 1's cancel, and I'm going to be 2 for 2 on remembering the minus sign. Equals limit as h goes to 0, minus h over h. Keep going. Root x plus 1. Now I'm just copying down what I have over there. Root x plus 1 plus root x plus h plus 1. So now I can cancel out the h's. And now I can set h to 0. Nothing goes wrong. So I get minus 1 over, here I'm going to do some simplifying steps. Root x plus 1, that's what that first thing turns into. This didn't have an h in it, so nothing changes. And then I get root x plus 1 plus root x plus 1. Okay. Equals minus 1. I have two of the same thing times each other right here. So I get x plus 1, the square root goes away, times 2 root x plus 1. Or I can say this is minus 1, 2 x plus 1, and then condense it very nicely to the 3/2. So, plenty of sadness and hurt along the way, but we finally got to the answer that we wanted. And this was part 11. This is definitely the most algebra intensive part, but possibly not the hardest. That would probably be the related rates.